Hey everyone, my name is Totidas, and in this video I'm gonna show you how to use tapped screws for your 3D printed parts. So let's get started. So first of all, I'm gonna just create a simple sketch for my model. So I'm gonna start creating, of course, a sketch. I'm gonna select XY plane and I'm gonna create any shape. It doesn't matter, it can be polygon, it can be circle, it can be rectangle. Doesn't matter. I'm gonna create a polygon. Circumscribe polygon. I'm gonna select origin point and I'm gonna say it's gonna be about 20 millimeters of diameter, and because right now it's not constrained, I'm gonna use horizontal vertical constraint for that line, and it's automatically becomes the lines becomes black, and it's automatically showing me that all those lines are constrained. Next thing, we need to create a cylinder, so basically two circles, and we're gonna extrude it. So the diameter of that circle is gonna depend of the screws you're gonna use it. So in this case scenario, I'm gonna use 2.9 millimeter screws with the length of 13 millimeters. So I'm gonna use 3 millimeters of the diameter, and I'm gonna give some offset or the thickness for that cylinder of 1.2 millimeters. So if you're thinking right now, why 1.2 millimeters? I mentioned in a couple of the live streams that the thickness depends of the nozzle size. So of course I could go just with 1 millimeter, it's gonna fill inside of those perimeters, but using 0.4 millimeter nozzle I can multiply it by 2 perimeters, by 3 perimeters. So by multiplying the 3 perimeters is gonna give me the result of 1.2 millimeters of the thickness. So that's why I'm using 1.2 millimeters. And I'm gonna finish the sketch, and I'm gonna select all those profiles, and I'm gonna extrude it downwards. So the short key for extrusion is E. So I'm gonna use minus 2 millimeters because I want to make that platform of 2 millimeters, but our sketch is gone right now. I can go back to the sketches and enable the sketch that we created. And I'm gonna select that cylinder, or for example the cylinder profile, and extrude it upwards. And how much we should extrude it, it depends of the screw. Like I mentioned, this is the 13 millimeters, but remember we're gonna create a box and or the top lid just to combine those two platforms and to use screw to make those things permanent, or at least permanent. So I'm gonna use something like 8 millimeters and it should work fine. So next thing is to insert the screw. If you have the model, you can just go to your file project, or I'm sorry, for your data panel, find your model and insert it. Or the best way is to go to the insert, find insert MC master car component, and find the screw that you are looking for. So I'm gonna go to the screws and bolts. I'm gonna find, let's select the metric. I'm gonna find where it is. Tapping wood and drywall screws should work fine. And I'm gonna select stainless steel Phillips rounded head screws. This is the rounded screw you can find in your local hardware store. If you're using a flat one, you have to select something like that. I'm gonna select this one. And like I mentioned, the length is gonna be 13 millimeters. And I'm gonna select the first one because the diameter is 5.6. If your head diameter is 6.9 or 7.5 diameter, you have to select accordingly to your screw that you have. So I'm gonna select 2.9, 30 millimeters, 0.59 diameter of the head. So I'm gonna select something like that. I'm gonna go to product detail, and it's gonna open the website, and I'm going all the way to the website bottom, and I'm gonna find something like 3D step, and sometimes it's gonna show you as 3D SolidWorks. You have to select 3D step file, and I'm gonna press save. After a couple seconds, it's gonna upload to our sketch, and I'm gonna just select the front view, and I'm gonna go upwards, something like that, 14, 15. I'm not gonna touch the bottom plate. I'm automatically gonna assume that it's gonna be captured with the position. And here, even though it's very hard to see it right now, we need somehow to make half cut. So the best way is to go to insert, selection analysis, and I'm selecting this profile plane and pressing OK. As you can see right now, the problem is those spiral taps, or the threads if you prefer in that way, it's barely touching the faces. I think it's not even touching. So the problem is the diameter of that inner circle or of that cylinder. So how we gonna calculate something like that? So either way you can play by the eye, just removing a couple of the millimeters, or the best way is to calculate the shaft diameter of that screw and the thread diameter of that spiral. So if I go to insert, inspect and select the measure, I can select that cylinder, and the diameter is 2.13 millimeters. So we know that the minimum diameter of our inner cylinder circle has to be at least 2.13. But of course we need some clearance. It was going to be something like 2.2. But keep in mind that we are using threaded screw. So we need to account for the thread itself. So as you can see, sometimes you can't just measure the distances between those threads. So I'm gonna use the measure tool one more time, select point A and point B of that spiral, and it's gonna give me the distance of 0.404 millimeters. So in the end, it's gonna be something like 2.5 millimeters of diameter. So I'm gonna go back to my sketch. Either way, it doesn't matter if you're going from the timeline or going from the sketch hierarchy. So I'm gonna change from 3 millimeters to, like I mentioned, 2.5 millimeters. I'm gonna finish my sketch, and as you can see, right now, if I enable selection analysis, those threads are touching the sides. We have extra clearance for expansion, and in the end, if you want, you can play with the millimeters. You're gonna give some offsets, you can remove it, but for the 3D printed parts, it should work fine. So it's gonna grab that plastic part of that cylinder. But the next problem is, if it's gonna be 3D printed, the problem is this is the weakest spot of our 3D printed part. So it's gonna snap at certain point of the stress. If you're using too much stress of the screw itself, it's gonna just pop it off. So we need to make it much stronger. The best case scenario, we can use fillets or chamfers. Fillets works fine, but it's not very recommended if you're using on a Z-axis. For example, if I use on these edges, on this edge or this edge, the fillets should work fine because 3D printers is capable of going on X, Y plane. But if you're using Z plane, so if you're going upwards, so each of the layer is gonna have some problems with the fillets. But for certain parts, or if we are very small, it's not gonna be a problem. So using fillets or chamfers here should work fine. So in this case, I'm gonna use the chamfer, and I'm gonna assume the chamfer is gonna be something like 1.6 millimeters. And it should work fine. It's much stronger than before, but still it can snap from those radius, from those fillets, from those chamfers. It's not strong enough for our project. So imagine if you have a couple of kilograms of the weight for that screw, it's gonna snap at the end. So in this case, I have a better solution, and it's much more recommended. So let's start creating another sketch, and let's select ZX or ZY plane. So I'm selecting ZX plane, and I'm gonna project that cylinder, and I'm gonna project that face of that polygon. So I'm gonna go to create, project. I'm gonna select that projection of the polygon and projection of that cylinder. So right now we have extra lines to work within. So I'm gonna go to the line. I'm gonna connect those 2 points, and after that I'm gonna snap to the middle point of that line. And I'm gonna go something like that. It doesn't matter. So right now we created something like a triangle. We can extrude it, but the problem is, if we extrude it, the problem is, as you can see, it's not gonna go around that object. So that's why sometimes it's much better to use the rib tool. So let's go to create, use the rib, select the line, and if something like that happens, the problem is the direction. So let's flip the direction. You can find on that tab, let's flip the direction, and it should work fine. And as you can see, it's gonna go around our object or model. So I'm gonna press OK. The thickness is 1.2 millimeters, should work fine. And if you want, you can do the same step over and over, but in this case, I'm gonna go to create, pattern, and circular pattern, because this is the cylinder. And I'm gonna go to pattern type of the features, gonna go to the timeline, this is our feature, and I'm gonna select the axis of that cylinder. 3 quantity or 4 quantity or 4 copies, it's gonna work fine. So as you can see right now, we made this part much stronger. It's not gonna snap, and it's gonna work perfectly for our project. Now, right now, if you want to, you can use some fillets, use some chamfers to make it nicer and stronger. But we need to combine those two models or two top and bottom lids. So I'm gonna create a top lid, using this polygon because the problem is right now I created as a one solid unit. I cannot use Ctrl C and Ctrl V. What I can do the same with the pattern. I can go to the pattern, rectangular, go to the type of the features, and the second feature was the extrusion of that polygon. And I'm gonna select that polygon, and the direction is gonna be Z-axis. I forgot to select object. Object is gonna be extrude, and I'm gonna go upwards a couple of the millimeters, and the quantity is gonna be 2. So after that, I have that same polygon that I created in the beginning of the video. Right now, I'm gonna just disable this polygon because there's 2 mandatory things to do right now. Either way, you can combine that screw. Let's disable the screw. You can combine that created cylinder with another cylinder for the screw itself. So for example, if I extrude it, let's say 5 millimeters, something like that, and create as a new body and combine with the platform I created and enable the screw, it should work fine. The problem is you have to align it perfectly, and sometimes those models can swift around it, it can slide it. So this would work perfectly for some of the cases, but if you want to make your model much stronger and much nicer, like I mentioned, this is the recommended way to do it. So let's create the sketch from that circle. So I'm gonna create the sketch and I'm gonna use that profile, and I'm gonna give some offset from outer ring. So I'm gonna give something like 0.2 millimeters. So because I don't want those sides to touch each other, sometimes 0.2 millimeters should work, sometimes 0.3 millimeters, and above that should work perfectly, but it's too much of the space. Going lower than 0.2 millimeters can affect, and you sometimes maybe if you're gonna spray paint or something like that, it's not gonna fit perfectly. So I'm gonna leave as 0.2 millimeters. So in the end, it's gonna be something like 0.4 millimeters in the diameter of the extension, but it should work fine. And the same I have to do to make outside of the ring, so to make another cylinder. So it's gonna be something like 1.2 of the thickness and plus of that 0.2 millimeters of the error or the offset I created. So it's gonna be something like 1.4 millimeters from the origin point or that circle I created, but in the end it's gonna be 1.2 millimeters of that diameter. Right now, as you can see, 1.4 millimeters. If I finish the sketch, use the inspection tool, that line and that line, the distances are 1.2 millimeters. So I'm gonna extrude it upwards and downwards. So how much have to extrude it upwards? Depending on the screw that you selected and the length of the shaft and so on. So I'm gonna enable the screw, I'm gonna extrude it upwards, and I'm gonna, rather than going upwards, I'm gonna select that face. And it's about something like 6 millimeters. I'm gonna change the direction to 2-sided, and I'm gonna go downwards like 2 or 3 millimeters. It's not touching, so it should work fine. So 3 millimeters should work fine. So I'm giving much more strength for that screw to hold in and to fit perfectly. So as you can see, the operation is new body because it doesn't combine everything. But if I enable selection analysis, as you can see, the problem is that screw can go over that cylinder. It's not gonna hold it well. So we need to make some sort of the support for that screw to hold in. Like I mentioned, the dimensions for that screw is 2.13 millimeters of the cylinder, 0.404 for the shaft distance. So basically, in the end, we have to use something like 3 millimeters to make sure that this screw goes through that hole without any problems, and gonna screw inside of that plastic that we created, or the plastic cylinder that we are creating. So I'm gonna just disable the selection analysis, enable body 3, disable the screw, gonna create this one more time, the sketch from the top of that circle or that selected plane or face, and I'm gonna give some offset of, gonna create this circle of 3 millimeters, something like that. And I'm gonna select that profile and I'm gonna extrude it downwards, so it's gonna be minus, let's say, 2 millimeters of the thickness. Should work fine. And now if I enable the screw and if I enable selection analysis, as you can see, this is how it's gonna look. So basically we have that clearance that is required for our threads just to pass over it, and it's not gonna interfere. And here that those threads gonna intersect with that model and gonna hold those two parts together. But as you can see, the problem is it's not going all the way to the end, so we are not required to do unless our model is supposed to have something like that. But in this case, if you want to, you can go extruding, or for example, if I use Q for the short key for press pull tool, as you can see, press pull tool, and if I go downwards, I can do the same thing here, so it's gonna snap to the end. But sometimes I'm not very happy with these functions or these calculations, because sometimes you're gonna have the problem with the model itself, and having those extra space gonna help you to make sure that those two 3D printed parts gonna be screwed together perfectly. So let's create the platform that I was talking about. So I'm gonna go over it, enable body 2, and I'm gonna disable selection analysis. I'm gonna move the body 2 upwards. And the next problem is, if I go next to that screw, the problem is, if you're gonna place your model on the table or on the solid surface, this screw gonna just scrape your table or something like that. We need to make sure that this screw is not gonna budge on that model itself. So at least we need to move that body upwards a couple of the millimeters. But before that, I want to remove that circle from that polygon. Either way, if you want to, you can create a sketch and remove it, or the best way is to use combine, select that platform, select that cylinder, and make sure the operation is cut. But keep in mind of that, if you make the operation cut and do not use keep tools check mark, it's gonna remove the body 3. So I'm gonna enable keep the tools, press OK. It's gonna leave my body, but it's gonna automatically, as you can see, it's automatically gonna make that cut easy enough without any sketches. And if I'm sure this body 2 is not required here to have it, so I'm enabling body 3, something like that. Let's make sure everything looks nice. Should work fine. So right now what we need to do is to make some extensions for that screw. Best way is to create another sketch, select that profile plane, and let's make some offset of around, let's assume 1.2 millimeters one more time. After that, I'm gonna finish the sketch, and in this case we need to extrude it upwards and downwards. So extruding upwards depends on the screw head height. So in this case, if you don't know the height, you can, by extruding upwards, you can select the highest point of that screw. So right now it's 2.091, so just to make sure, in the safe side, we can go to something like 2.4 millimeters. Should work fine. And the direction from one side to two sides, and let's go downwards because the operation is the new body. I want to have something like join command, and because the platform height is 2 millimeters, we're gonna go 2 millimeters downwards. So 2 millimeters should work fine. And after that, if I enable the platform, as you can see, should work fine. But we need to move the platform upwards. So let's move upwards a couple of the millimeters. If it doesn't work, something like that, you can at least select the top face and it should work fine, as you can see. And we can remove that 2 millimeters of the offset and should work fine. We have the extra lip here, but because we want to make sure that those two parts are combined together, we're gonna leave it as it is. We can change it with the fillets, with the chamfers, make it stronger, the same thing that we did here before. And I'm gonna go to combine, select that platform, select that cylinder, and the operation gonna be join, and let's remove keep tools. And after that, it should look something like that. And I'm gonna go to modify, select the chamfer, select the inner circle, and let's assume it's gonna be something like 0.8 millimeters. So just to make sure that this screw is gonna go inside without any problems, so it makes our life easier. So we created the platforms, and we need to make sure it's looks something like a box that is gonna be screwed with the tapped screw itself. Easiest way is to go to the surface. Let's extrude the polygon profile, and let's go upwards. And the problem is it's extruding everything that is selected, but we can remove after that. And I'm gonna select that face. So the height is gonna be 14.4 millimeters, something like that. And as you can see, we have body 5 and body 6. We can remove body 6, we are not required to have it, because this is the surface, it doesn't have any thickness. We can go to the create tab and go to the thicken. Select the body 5, and automatically it's gonna assume that it's gonna be something like 2 millimeters of the thickness, and I'm gonna press OK. If I enable selection analysis, those three parts are not connected together. So basically, if it's our top lid, I'm gonna go to combine section, select this top lid, select those walls, and it should work fine. As you can see, we don't ever needed to go all the way up to that screw, because this screw holds all that base for our main purpose. But the problem is, because this shape is polygon, so imagine if you have a let's say a square or something like that, if you rotate at least a couple of millimeters, it's not gonna align perfectly. So the best way to make sure that your component stays in the same place, if you are using, for example, one screw, is to make some at least the tabs to hold in. So let me demonstrate what I'm talking about. So let's create the sketch. Let's select the profile, and if you remember, we created the thickness of the walls of the material of 2 millimeters. So we need to go to offset tool and offset at least 2 millimeters inside of that material. So basically this is 2 millimeters for the thickness of our material, but we need to have at least extra offset for our tabs to connect. So let's assume it's gonna be 2.2, something like that. It can be 2.1, 2.2, just have that extra safe distance. So let's assume 2.1, should work fine. And let's offset it one more time, and it's gonna be minus 2.1 and minus 2. So okay, not minus 2, minus 0.8 millimeters. So I created the thickness of the wall of 0.8 millimeters. So it's basically 2 perimeters for 3D printer. And why we should go thicker if you want to, but having the thinner walls makes a little bit of the deformation. If you want to make, for example, the snap fittings or something like that, just to make sure that 0.4 millimeters and 0.8 millimeters is the minimum, at least the thickness, if you want to make snap fittings for your 3D printed model. So going above that, for example, if you're gonna use 3 millimeters of the thickness for the walls, it's not gonna work. It's gonna just snap or not gonna be removed at all. So 8 millimeters should work fine. So I'm gonna press OK, and after that I'm gonna finish the sketch, and I'm gonna extrude that wall. So let's assume it's gonna be about something like 3 millimeters. So right now, if I enable body 4 and enable selection analysis, as you can see from the front view, we have that extra gap that is required, and it's not gonna interfere with our model, and those extra faces, so it's not gonna budge at all. So basically it's very easy just to combine those two models. Of course, it's not the strongest connection here, so that's why we have to do extra steps to finish our project. So the best way is to go to modify, let's use chamfer, select the edges if you want to, and should work fine. So let's select the edges, this one, this one, this one, all the 6 edges. Okay, the wrong one, this one, and this one. And let's say it's gonna be something like 1.2 millimeters. And it should work fine. Next thing, if you have some wires coming up and for example USB ports, something like that, you want to make the cuts of that wall. So if you want to, you can go to the create tab, go to the box, something like that, and let's make some extra cuts. And I'm gonna go downwards. I made some extra cuts, and this is only the one wall. If you want to, you can make more cuts if you prefer. In that way, you can go to the create circular pattern. So yada yada yada. So you know what I'm talking about. And I'm gonna select the axis of that cylinder, and I'm gonna create 6, and should work fine. As you can see, we made 6 cuts, and if I enable body 4 and enable selection analysis, it should be looking something like that. So it's not gonna be a problem for your 3D model whatsoever. So thank you for watching, and I hope this video was helpful. See ya.